All right, so get this. We're diving into the world of shrimp today.
Shrimp.
Yeah, shrimp. You might be thinking shrimp, really. But trust me on this one.
Okay.
This is not your average seafood buffet. We're talking caridina types. A tiny shrimp with a huge meaty story. And you sent us this research paper on them, and wow.
Yeah.
We're talking evolution, ocean voyages, even what it really means to be a species.
It really does make you think about species differently.
It does. So first things first.
Okay.
Picture this. Caridina typhus hanging out in freshwater streams and rivers butt, and this is a butt, always near the sea.
Near the sea, that's unusual.
Right. And get this, they're found across this huge G area from East Africa to the Polynesian Islands.
Wow, that's a long way.
That is a long way for a shrimp to travel, and that's just the beginning.
So what makes these shrimp so special? I mean, what's the deal with the sea?
Well, they have a larval stage, right, where they drift in the ocean, but they can even tolerate salt water as babies. Most freshwater species, I mean, they can't stand salt.
Right, that's very unusual for freshwater species.
Exactly. So it's like, what makes these guys so special?
So they have this weird ability to tolerate salt. I bet that's a key part of how they ended up spread out all over the place, right?
It has to be, like some kind of secret shrimp superpower.
A shrimp superpower, I like it.
So they're found in this massive area. They're weirdly good with salt. What else? What else makes them so interesting?
Well, for a long time, scientists, they thought caridina typhus was just one big happy species.
Okay.
But then, DNA analysis.
DNA analysis. Always finding those secrets.
Well, the DNA revealed something pretty astonishing. Within what we call caridina typhus, there are actually 3 distinct lineages.
Wait, 3? So you're saying we've got multiple shrimp lineages hiding in plain sight?
That's exactly what I'm saying.
It's like finding out your identical twin isn't so identical after all. So we've got these shrimp, they look the same, but their DNA is telling a completely different story.
You got it. Scientists, we call this cryptic species. Groups that look the same on the outside, but genetically, they're totally distinct.
Cryptic species. Okay, so how do we even begin to tell them apart?
It all comes down to the DNA. By comparing the DNA sequences of different populations, we can trace their ancestry, how they're related. We can even make an educated guess about when and where they migrated.
So we're talking shrimp detectives, huh?
You can see that.
Analyzing clues from millions of years ago.
Exactly.
This is incredible. So we've got 3 lineages disguised as one unassuming shrimp.
And that's just the beginning of the story.
I can't wait to hear more, but first, a quick break. Analyzing clues from millions of years ago. This is amazing. So we've got these 3 distinct lineages, all disguised as one unassuming shrimp.
And that's just the tip of the iceberg.
Okay, so how did we go from 3 lineages to a global shrimp empire? Did they hitchhike on coconut or something? What happened?
Well, it wasn't quite as simple as hitching a ride on a coconut, although that would be a pretty good story.
Right.
The researchers, they used a technique called molecular dating.
Molecular dating. Does that mean what I think it means?
It does. Essentially, it's looking at changes in DNA over time.
So we're talking shrimp detectives analyzing clues from the distant past.
Exactly. By looking at how much the DNA has changed between the lineages, you can get a sense of how long ago these occurred.
Okay, so molecular clock ticking. What's the verdict? How old are these lineages?
Get this, it all seems to have kicked off way back in the Miocene epoch.
The Miocene.
Yeah, roughly 23 to 5 million years ago.
Wow. Okay, so we're talking serious ancient history here.
Oh, absolutely. And the Miocene, it wasn't just any old epoch. This was a time of major geological upheaval, especially in the Indo-Australian archipelago, where our shrimp friends are from.
Wait, wasn't that when volcanoes were erupting left and right? Continents were playing bumper cars?
Exactly. We're talking about islands forming, disappearing, colliding. Talk about a dramatic backdrop for our little shrimp friends.
Wow, what a time to be a shrimp, right?
No kidding.
Yeah.
And this turbulent environment, it played a huge role in shaping their evolution. I mean, it likely contributed to these lineages diverging from one another in the first place.
So we've got a restless planet, we've got adventurous shrimp. What's next? How do we trace their journey?
All right, so get this. Researchers use something called ancestral range reconstruction.
Ancestral range reconstruction. Okay, you're gonna have to break that down.
Basically, by analyzing both the DNA and the shrimp's current distribution, we can make an educated guess about where their common ancestor likely lived, like piecing together a giant puzzle, but instead of cardboard, it's with DNA.
Okay, so it's like a family tree, but for shrimps.
Exactly. We're tracing their roots back to the source.
Okay, so drum roll. Where did this shrimpy family reunion begin?
All signs point to Africa.
Africa? Seriously?
That's right. Africa seems to be the starting point for this global shrimp adventure.
Wow, talk about an epic journey.
Right. But it gets even better. They believe these shrimp may have hitched a ride on a prehistoric ocean current.
A prehistoric ocean current? Come on, now you're just messing with me.
I'm serious. They call it the Miocene Indian Ocean Equatorial Jet, or the MIO jet for short.
The MO jet! Okay, that's way cooler than a coconut.
Right.
So these tiny shrimp larvae were just cruising across the Indian Ocean, swept along by this powerful current.
That's the idea. It really puts our daily commute into perspective.
No kidding. But hold on a second. If this MIO jet was so crucial, how did they end up all over the Indo-Pacific? I mean, that's a pretty big detour, right?
You're right, there's another twist in this tale. As the continents continued to drift and rearrange themselves, the MIO jet eventually closed off.
Closed off. So what happened to the shrimp?
Well, this closure, millions of years later, actually paved the way for what we call back dispersal.
Back dispersal. So they made a U-turn.
Essentially, yeah. One of the lineages actually rode the currents back from Africa towards Australasia.
So it's like a shrimp boomerang.
Exactly. It's incredible how these ancient currents acted as islands, shaping the evolution and distribution.
Okay, I have to ask. We keep saying lineages, and we know they're genetically distinct, but they look identical. How can we be sure they're really different species and not just, distant cousins?
That's a great question, and it gets to the heart of how we define a species, which, believe it or not, is a lot more complex than you might think.
Oh, I bet.
So the researchers, they didn't just stop at DNA analysis. They used several different, what we call species delimitation methods, different ways of analyzing the data to figure out if these groups are truly distinct species.
So they threw the whole scientific toolbox at it.
Exactly. And here's the kicker. All the methods, they all pointed to the same conclusion.
Let me guess. 3 separate species.
2 separate species.
So we've got 3 groups of shrimp that look the same to us, and their DNA is different. Story.
Precisely. And this is what we call cryptic species. Groups that look identical but are genetically distinct. It really challenges how we define a species.
It's like those magic eye pictures where you can't see the hidden image until you look at it a certain way.
Exactly.
We thought we were looking at one species, but there's a whole other level of complexity hiding in plain sight.
And this discovery, it opens up a whole new can of worms, a whole new set of questions about how species evolve, how they diversify, all because of this tiny shrimp.
My mind is officially blown. Okay, so we've got our 3 intrepid shrimp lineages here crisscrossing the oceans on historic currents. Now let's talk about the stage, the Indo-Australian archipelago.
Ah, yes, the IAA. A dynamic region, to say the least.
Dynamic. That feels like an understatement, right? I mean, we're talking about islands popping up, disappearing, smashing into each other.
It's true. Picture a giant jigsaw puzzle. But the pieces are constantly shifting and rearranging, and all the while, our shrimp are trying to find a place to call home. This dynamic setting had a huge impact on how these shrimp lineages evolved. Talk about an obstacle course.
It's like a shrimp ninja warrior course.
Right. And then, right smack in the middle of all this, you've got the Indonesian through flow.
The Indonesian through flow. Remind me what that is again.
Oh, it's massive, like a giant oceanic freeway. All these different currents flowing in and out, connecting the Pacific and Indian Oceans. It's like Grand Central Station for marine life.
And I'm guessing our little caridina typhus friends take full advantage of this freeway system.
Oh, absolutely. The Indonesian through flow, it helps explain how they conquered this incredible archipelago, hitching rides on these currents.
It's like the ultimate shrimp taxi service. So, with all this travel and mingling, I have to imagine things got a little crowded, right? The paper mentions something interesting about the Philippines. It really is like a giant oceanic freeway with lineages hopping on and off, right? Going to all these different islands.
Absolutely, it's incredible. And speaking of mingling, you brought up the Philippines earlier. And there's a good reason the researchers were drawn to this region.
The Philippines! What's so special about the Philippines?
Well, get this. The Philippines is the only place where all 3 caridina typus lineages are found living together.
Wait, hold on. Are you serious? After millions of years of evolving separately, riding these currents, we're talking millions of years, they all decided to have a family reunion in the Philippines. What's going on here?
It's a really good question. And the researchers, they propose a couple of possible explanations.
Okay, let's hear them.
One idea is that the Philippines, it acted as a kind of evolutionary crossroads. Remember that shrimp melting pot we were talking about earlier? Well, the Philippines, it might just be the ultimate melting pot. All three lineages come together, intermingling over time.
So after millions of years apart, they decided to meet up and swap stories.
Something like that, yeah. But we have to remember, these lineages, they haven't seen each other in millions of years.
Right.
They've been evolving independently, they've adapted to their own unique environments.
So are practically strangers at this point.
Exactly. And they might even evolve some reproductive barriers that would prevent them from interbreeding. Think of it like trying to have a conversation with someone who speaks a dialect you haven't heard in centuries.
So even though they look the same, they might as well be speaking a different language.
Exactly. Now, the researchers, they also propose another possibility that throws a real wrench into our understanding of how evolution happens.
Okay.
What if what we're seeing in the Philippines, this mingling of lineages, it's just a snapshot in time, a single frame from a much longer film?
Okay, I think I see where you're going with this.
It's possible that these lineages, they're actually at different stages of dispersing through the region, right? One might be just arriving as another one's passing through, so the Philippines is not necessarily their final destination.
Just a pit stop along the way.
Exactly. And that's what makes the Philippines so fascinating for this research. It's like a natural laboratory where we can actually study how these lineages interact in real time, giving us clues about how species boundaries form, how evolution happens in the wild, and ultimately what it actually means to be a species.
Yeah, this is incredible. So much of what we thought we knew about the caridina typus has been turned completely upside down.
No, it's exciting. And the craziest part is we've never scratched the surface.
Really? There's more.
Oh, absolutely. And the researchers, they even suggest a really interesting avenue for further research. They want to look at the size of the eggs and larvae in the different lineages.
The size of their eggs and larvae, that's a pretty small detail.
It does. But even small differences in these early life stages, it could explain how some lineages were able to travel farther, adapt to different environments better.
It's like the difference between setting sail in a canoe versus a massive cruise ship, right?
Exactly. It's a tiny advantage that snowballs over millions of years.
This has been an amazing deep dive. You know, I never thought I could learn so much from a tiny shrimp.
I told you.
We've covered ancient ocean currents, shifting continents, cryptic species, and we even touched on the very definition of what makes a species. It's pretty remarkable.
It is. It's a good reminder that even the smallest creatures can hold the biggest secrets about our planet, about how evolution works.
Absolutely. And to our listeners, the next time you see a shrimp, I don't care if it's on your plate or in an aquarium, take a moment and think about the incredible journey it took to get there.
Millions of years in the making.
Exactly. You might just be looking at millions of years of evolution, a story of epic ocean voyages, maybe even a few cryptic cousins along the way. Thanks for joining us for this deep dive into the fascinating world of caridina typus. Until next time,